So now in this video we're going to look at a diode logic gate. It's an OR gate. We have two inputs and we can make it where the LED is on if one input is high or if the other one is high, and then with OR gates they can all be high as well. The output is on. So the way we have this wired up, we are this is a mechanical switch, schematic symbol, single pole, double throw because of two positions right there. And you wouldn't actually use a mechanical switch like that. We're just using jumpers to simulate a mechanical switch. We could just have a couple switches that just connect to the positive supply, and then we wouldn't even need these diodes. Either one of them can switch the LED on, and if they're both switched on, no problem. But here we're basically simulating a digital output like the 555 timer output and a whole bunch of other integrated circuit outputs. They either connect, usually it's to ground really well, some of them not as well, but it makes a connection to ground, might lose a little voltage. And most of them can connect to the positive supply, probably lose some voltage, but usually they connect to the positive supply pretty well. It's two positions, either high or low. So in that case, you would need the diode. So I'm going to set this jumper back to high right now. So you can think of plus 5 volts there, and that's going to go through the LED and the resistor there to ground. So we have the cathode right there headed towards ground. Same with the LED. Short lead is the cathode there. And then we got a gray band right over there for the diodes to know where the cathode is. So you can see current flows that way. But we have this jumper switch, whatever you want to think of it as, connected to ground. So we have the potential of current flowing that way. But the diode blocks current flowing that way. So when this side's more positive, that side's more negative, it blocks current. That's the only way that current can flow. That's why we need the diodes in this particular circuit. So again, with mechanical switches, you can wire up where you don't need diodes. But digital circuits, you do need the diodes if the output connects to either the positive supply or ground. And then there's pull-up resistors too. You would also use those. So this diode, I'm going to add a little bit more. I'm going to cover this in more detail in the next video. But I'm using the 1N4001. So you can pretty much assume that if you see the black package right there. And I also have the 1N4148. So let's just quickly go over some of the distance. In this circuit, doesn't matter which one you use. Pretty much exactly the same. The 1N4001 that we're using here, 1 amp of current can flow through it, and it will that's a maximum continuous current, and it will block up to 50 volts across it. So we're far less on both of those in this circuit. If we swap these out with the 1N4148 right here, then we could put up to 300 milliamps of continuous current. Again, far more than we got here. We don't have to worry about that. And we could put 100 volts reverse bias, so even better. But there's the 1N4002, which can handle 100 volts. And then there's higher number ones up to 7 that can handle even more voltage, a lot more voltage. So there are alternatives there, but this can handle 100 volts. Also, this one, according to Wikipedia, you could have a circuit that switches on and off at a frequency of 100 megahertz approximately, according to Wikipedia, not the data sheets. I always consult the data sheets. It says a 4 nanosecond switching time, whereas the 1N4001, it doesn't even tell a switching time or frequency or anything. But Wikipedia says 15 kilohertz is about the max you can expect from this. So I'm going to assume that they're right. I don't want to test that out or anything. But in any case, I'm going to cover that in more detail in the next video. But for now, we'll take a closer look at the circuit there. You can see the gray band. And it's really easy to see the part number of the 1N4001. In fact, it looks like might be good enough to look at it there. So I'll do that next video.